All right, so this is 5-3 multiplying polynomials. Mark, if I give you a stack of papers and I say, hey, Mark, can you distribute this? What do you do with the stack of papers? Give everybody. So all we do with multiplying polynomials is we are going to pass out the numbers. And that's this whole section in a nutshell. Okay, so here for A, we distribute the 2 to the x and to the -5. So 2 times x is 2x, and 2 times -5 is -10. So A just becomes 2x minus 10. Does that make sense? Right? Are we okay with that? Rachel, are you okay with that? Emily, you okay with that?
Yeah.
Okay.
Yeah, I know. We already talked about this. It's unfortunate. I somehow didn't put it up. It was rough.
All right, let's go to B. With B, the only thing we have to pay attention to is what to do with variables, okay? So we know we're going to distribute this 4z to each of the two things in the parentheses, the 6 and the -3z. But here's the thing. When I do 4z times 6, that's 24z, because I did 4 times 6 and I got 24. All right? But now when I do 4z times -3z, well, 4 times the -3 is -12. All right? No biggie on that. But z times z, well, when we were talking about exponents and the powers in 5-1, z times z, we added the exponents. So this I actually find confusing because there are no exponents. So z times z is z squared because it's understood that there's a 1 there and 1 there. Okay? But Mr. Kitchen, I find a problem like C, even though it looks more complex, to be easier to understand than a question like B. So we're going to distribute this x cubed throughout. All right, so I'm going to do x cubed times x to the 4th. So I'm going to add the 3 and the 4, and I get x to the 7th. Do you see that, Mr. Kitchen? That's easier to see than how does z times z give me z squared. You can see that 4 times 3, like we're adding right there. X cubed times -2x cubed, that's going to be -2x to the 6th. Because I did x cubed, I'm going to add those exponents, and there we go. X cubed times 5x, that's going to be 5x to the 4th. And I'm going to do x cubed times -6, and that gives me -6x cubed. Not too bad, right? I haven't done anything funky, right, Mark?
Yeah.
Marcus, you with me?
Yeah.
Now, with D, the trick is, well, I have to make sure I multiply by a -3. Some people will forget the negative, okay? It's inevitable. But just remember that's why I'm drawing the arrows, so I know that I'm distributing that -3. So -3a squared times 8 is going to be -24a squared. -3a squared times -2a, that's going to be +6a cubed. Because -3 times -2 is 6. A squared times a, that's a cubed. -3a squared times -a squared, well, that's going to be +4, or positive 3a to the 4th. So, Mark, one more time, -3a squared times 8 is -24a squared.
Yeah, that makes sense.
-3a squared times -2a, well, -3 times -2 is 6. A squared times a is a cubed. And here I have -3a squared times -a squared. That's going to be positive, because a negative times a negative is positive, 3a to the 4th. Why don't you guys try 1 and 2? So let's tell them on Monday, word got out that this hedge fund was betting on GameStop to lose. And like, word was like out last week and stuff like that. GameStop was like $4 like a share a month ago. And then it like slowly crept up because people are like, that's wrong. You shouldn't bet on a company to lose. Like, I know this is the stock thing, but basically you're buying so many shares, you're causing this company to go under. Like, if it goes under, it goes under. So people found out about it on Reddit and they got real upset about it. So they started buying the shares. They're like, buy and hold, buy and hold. So many people did this against it. The hedge fund bought it at $20 a share. Well, now it's up to $340 a share.
Wow.
So the hedge fund was betting on GameStop to lose. So now they're on the hook for $320 per share, and it gets cashed in Monday. So they have to settle up no matter what on Monday. So they said this morning they were out. They got out. This morning it was $350 a share.
Wow.
They said they're out. Now, we don't know if they are. We think they're blowing smoke, but, you know, maybe they are, maybe they aren't.
Right.
So this like penny stock is just going bonkers. So here we go, Mark. Here you should have 10y minus 2y squared. So what you got?
Yeah, how come the 10y?
2y times 5 is 10y. 2y times negative y is negative 2y squared. Owen, are you with me, buddy? On that?
Yeah.
Now, here with number 2, we're going to distribute that throughout. So negative 2m squared times 7 is going to be negative 14m squared. Negative 2m squared times negative 4m is going to be positive 8m cubed. Negative 2m squared times negative 2, or positive 2m squared is going to be minus 4m to the 4th. So that's what you should have had. Mr. Kitchen, is that what you had?
Yeah.
Garrett, is that what you had?
Yeah.
Awesome. Now, I'm not a big fan of FOIL. A lot of teachers like FOIL. I'm not a big fan of it because I just think it's kind of like PEMDAS, okay? Kids get like stuck on the word FOIL. Now, FOIL, since it's in our notes, and you know, so many teachers use it, it stands for first, outer, inner, and last. Now, what this means is I'm going to multiply the first term on the left with the first term on the right. So I do 2y times 5y. That's 10y squared. Then I do outer, which stands for the one that's on the outside, okay, on the outer side of the parentheses, with the one on the outer side on the right side. So the 2y times the negative 1. So that's negative 2y. And then we do the inner, which are these two inside. They're the ones next to each other inside. So 3 times 5 is 15. So that's 15y. And then we're going to do last, meaning the last one on the right with the last one on the left. So it's going to be negative 3. Now notice, Rachel, we have the green and the red, and they both have y's with them, right? They are like terms. So what I have to do is I have to combine my like terms. So I have 10y squared plus 13y minus 3. And that's my answer. One more time. First, so 6a times 2a, that's 12a squared. Outer, that's going to be negative 18a. Inner, that's going to be negative 2a. And last, that's going to be a positive 3. Getting close. Yeah, close enough. Now, real challenge is I got to combine my two middle terms there. So I have 12a squared minus 20a plus 3. I was so worried about that. Whew. Now, you guys try. While I align my board, you guys try the two below. Okay. Now, FOIL is great, but there's another way to do it. Hopefully you did it through FOIL, all right? But watch what I do here. This is called the box method, and I like the box method better than FOIL because moving forward into the example 3, notice FOIL won't work. I don't have a first, outer, inner, and last. I have like a first, outer, first, inner, and last. Like I have a lot of numbers going on in that second one. So what I like to do is the box method. Now I like to view this as trying to find the area of a box. Okay, the expression on the left represents my width. The expression on the right represents my length. So on the width expression, the expression on the left, I have two terms, the 3x and the 1. So I divide my box in half. 3x goes on top, and the 1 goes on bottom. Do we all see where I get the 3x plus 1 from? On top, I have an x minus 4. So I have two terms, an x and an x minus 4. Now, what I do is I'm going to simply multiply 3x and x. That's 3x squared. Notice that gives me my first box. And I like this because it keeps me organized. Okay? It's easy to see. 3x times negative 4 is negative 12x. 1 times x is 1x. And 1 times negative 4 is negative 4. And now from here, I simply combine my like terms. So 3x squared, there's nothing like that. And then typically along my diagonals, okay, are my like terms. Notice negative 12x and 1. So that's going to be negative 11x and negative 4. And there we go. So that's what you should have gotten for the first one. Okay. For this one, okay, again, using the box method. I have 2x minus 6 on the top and 5x minus 2 going down the side. So 5x times 2x is 10x squared. 5x times negative 6 is negative 30x. Negative 2 times 2, that's going to be negative 4x. And negative 2 times negative 6 is positive 12. Combine my like terms. We have 34x and plus 12. Jagger, did you get that?
Yeah.
Cool. Mark.
We do, but we still have that like the second the exponent. We used to not need the 5x times 2x. Why is it not just 10x? Why is it got to have the square?
Because x times x, okay, when we're multiplying, the x has an exponent of 1, and this one has an exponent of 1. And remember, in 5(1), we added the exponents. So 1 plus 1 is 2. That's why it's x squared. And here's really why the box method is way better than the FOIL method. All right, FOIL's, there's nothing wrong with it. I'm not bashing FOIL, okay? But it's just, it's only good for one case, all right? So here, I can't really FOIL this, so I would have to distribute. Okay, so I'd have to distribute the z times z squared and z times negative 4z and z times the 4 and then 2 times the z squared. And there's just a lot going on. But with the box method, draw my box. On the left, I have two terms, a z and a 2. Along the top, I have three terms. So I divide my box into threes along the top. So I have z squared minus 4z plus 4. And now I'm going to multiply the two pieces along the box. So z times z squared is z cubed. Z times negative 4z is negative 4z squared. Z times 4 is 4z. Going along the bottom now, 2 times z squared is 2z squared. 2 times negative 4 is negative 8z. And 2 times 4 is 8. And again, you can see my like terms are along the diagonal. It won't always be like this, but I feel it's easy to kind of see your like terms here. And I also like to cross out my boxes once I've wrote them for my final answer. Now, why did I say it's not always going to be like that? Well, the next question is kind of where it differs. And the reason is, notice there's a linear term missing here. So that's going to shift my box around. It doesn't change how I set it up, but you'll see that my like terms are kind of in different spots. So we have 2x squared minus 3. All right, we have 2x squared minus 2x plus 3. And then I'm going to do 2x squared times 2x squared. That's 4x to the fourth. 2x squared times negative 2x is going to be negative 4x cubed. 2x squared times 3, that's going to be 6x squared. Negative 3 times 2x squared is going to be negative 6x squared. Negative 3 times negative 2x is going to be 6x. Negative 3 times 3, that's going to be negative 9. So we can see 4x to the fourth. But now notice negative 4x cubed and negative 6x squared, they're not like terms, but it's still easy for me to say that I have negative 4x cubed. Now I have negative 6x squared and 6x squared, they cancel. Plus 6x and minus 9. Now I'm going to quit while I'm ahead and my board doesn't go completely haywire. So what I want you guys to do is I want you to answer the you try. I'll put up the answer, okay, and you compare your work to the answer. My board just hates me today. Yep. Rachel, did I get it right? Thank you. All right. Now, here's what I want you guys to do is I want you guys to work